Hello everyone, Dr. Polaris here. Home to about a quarter of the Earth's total population, as well as a staggering array of animal and plant species, South Asia is, as its name suggests, a part of the Eurasian landmass today, although this was not always the case in the past. The origins of the subcontinent, that includes the nations of India, Pakistan, Bangladesh, Sri Lanka, Nepal and Bhutan, lies in the old supercontinent of Gondwana. During the early Cretaceous, this massive southern landmass began to split apart into smaller divisions. South America and Africa drifted away from each other, forming the first inklings of the Atlantic Ocean, while Australia and Antarctica remained connected in the South Polar region. To the north, meanwhile, by roughly 105 million years ago, a large island, consisting of what is today Madagascar and India, sat off the southeastern side of Africa. By the late Cretaceous, about 88 million years ago, Indo-Madagascar itself began to split, with the Indian portion moving north at a fairly rapid pace, while Madagascar remained off the coast of Africa. By the Maastrichtian, when India had become distant enough from neighbouring landmasses to be considered its own small island continent, the region had entered into a humid tropical to subtropical climate zone, with studies focused on the Deccan area of western India, revealing a mixture of swampy, mangrove and closed forested ecosystems. The plants present here show some similarities with those of the modern Western Ghats, an area of high endemism as we shall see a bit later, and included palm trees, the oldest known species of the still living Dipterocarpus, and fossil grasses related to rice and bamboo. A variety of non-avian dinosaurs were found in Maastrichtian India, with titanosaurian sauropods being relatively common and diverse herbivores. These include the unusual Aitchison, a medium-sized titanosaur with oddly elongated forelimbs and a short, upward-oriented neck. Unsurprisingly, this animal was a close relative of the Malagasy Rapetusaurus, with its build indicating a specialised high-browsing niche. It lived in the Lameta formation of central India, along with Jainosaurus, which measured about 18 metres or 59 feet long and weighed in the region of 15 tonnes. The remains of other herbivorous dinosaur groups are very rare and fragmentary. Potential ankylosaur osteoderms have been found, in addition to fossilised footprints that may belong to a stegosaur of all things. Although this group of armoured dinosaurs is thought to have died out during the mid-Cretaceous about 100 million years ago, fragmentary fossil material attributed to stegosaurs has been recovered from late Cretaceous India. The identity of this material has given rise to much debate, with the purported poorly preserved stegosaur Dravidosaurus from southern India, and dated to circa 89 to 86 million years ago, sometimes considered to be a fragmentary pliosaur. However, in 2017, Peter Galton and Krishnan Ayasami reaffirmed that Dravidosaurus was a stegosaur, and announced that further likely stegosaurian fossils from the same original site were currently being studied. The authors also considered it plausible that these armoured dinosaurs may have survived into the Maastrichtian in India, as the then island subcontinent was home to other late surviving members of older clades. These include the potential haramiyid Avashishta, a small, vaguely rodent-like animal known from a single molar tooth. Haramiyidans were possibly closely related to multituberculates, although have more often been considered to be outside crown group Mammalia. If Avashishta really was a haramiyid, something that has not been robustly tested, then it would represent the youngest non-mammalian synapsid to ever live. Another late survivor was the genus eutriconodontan, a carnivorous mammal or mammalia form that was a member of eutriconodonta, a lineage of sometimes large meat-eating mammals that were widespread on the northern continents until the beginning of the late Cretaceous, when they went into decline. Their remains are very poorly known from the southern hemisphere, although the American badger-sized Indotriconodon establishes that they were present in former Gondwana until the end of the Cretaceous. Living alongside this eutriconodont was the Gondwanathia baratherium, a herbivorous rodent-like grazing mammal with high-crowned cheek teeth that indicates a diet of tough vegetation and grasses, which have been found in Maastrichtian India. However, the most common mammals from this region are the eutherians, including the potential herbivorous gelestid Caramegungulatum, and the insectivorous Decanalestes. These small mammals would have been hunted by several species of the carnivorous Noasaurids, which probably reached roughly 2 metres or just over 6 feet in length, with only one receiving an official formal scientific name, being Levi-suchus. The top-order carnivores of Maastrichtian Insular India were the closely related abelisaurs, a group of short-faced, short-armed predators that were widespread across the Gondwanan landmasses. Several species of these have been described and named from India, including the 7-metre-long Indosuchus, the relatively gracile 6.5-metre Rahiolisaurus, and the robust, stocky Rajasaurus, which was a close relative of the Malagasy Majungasaurus. These would have hunted the contemporary titanosaurs by utilising ambush, grabbing hold of the herbivores with their blunt snouts, using a bite and hold strategy reinforced by their strong muscular necks and sturdy skulls, which could absorb a great deal of stress. In addition to these predators, 2 species of basal snakes were present, including the 11-foot-long Sanaje, which is known to have preyed on hatchling sauropods and their eggs. The other was Matsoia pistorensis, an even larger 5-metre-long, superficially python-like snake that belonged to the widespread Gondwanan family Matsoiidae. We'll be hearing more about this group of snakes later. Looming over all of these animals was the Deccan Traps, an area of massive volcanic activity located in what is now western India, and covering an area of roughly 1,500,000 square kilometres at its maximum. The eruptions occurred over a 600 to 800,000 year time period, between around 66.3 to 65.6 million years ago, spanning the Cretaceous-Paleocene boundary. While some scientists have suggested that the eruptions were the primary cause of the Cretaceous-Paleogene extinction event, which dates to around 66.5 million years ago, this has been strongly disputed, with many authors suggesting that the Chicxulub impact was the primary cause of the extinction instead. Regardless of this, the Deccan volcanism combined with the effects of the bolide impact had a devastating effect on India's Maastrichtian fauna. The vast majority of animal groups were wiped out, with the aforementioned mammals Baratherium and Decanolestes surviving into the early Paleocene before vanishing. Only 3 extant tetrapod groups have representatives that can be verified as descending from the Gondwanan endemics of Insular India. These include one family of frogs, Nasciabatrachidae, several families of the legless Sicilian amphibians, and one family of blind snakes, the Geholopidae. Notably, all 3 lineages have a fossorial lifestyle, indicating that this may have saved them from the extinction's impacts. Other groups, such as the Matsoiid snakes, would also survive into the Cenozoic, but went extinct before the Holocene. Among invertebrates, survivorship was more common, with several families of modern Indian centipedes, mussels, and mantises having ancient Gondwanan ancestry. After the KPG extinction event, India continued to drift northwards at a fairly rapid rate of about 20 centimetres per year. Paleocene-aged fossils are incredibly rare and fragmentary, so it's difficult to reconstruct what its faunal communities would have been like. Placental mammals probably arrived from Eurasia at this time, possibly by island hopping or floating on mats of vegetation. It has been suggested that the common flying ancestors of the Paleonath kiwis and Malagasy elephant birds may have originated in India before flying further south. By the early Eocene, the situation becomes much clearer, with India having its own diverse array of placental mammals, some of which seem to have been endemic to the region. These include the Anthracobunians, a lineage of hoofed mammals that were probably basal relatives of perissodactyls. They would have somewhat resembled small trunkless tapirs, and fed on soft plant material, with isotopic studies indicating that they lived near water. Several species have been found in the early Eocene Kuldana Formation of Pakistan, which dates to between 50 and 45 million years ago, and gives us the best insight into this interesting time in mammal evolution. This ecosystem was arid to semi-arid in nature, being crisscrossed by rivers and estuaries that supported denser areas of vegetation. The formation was always in relatively close proximity to the coast, with marine ingressions being common. The most numerous animals found here were a variety of ungulates, including the tapir-sized Brontothere Pacotitanops, the small rabbit-sized Diacodexid artiodactyl Gujaratia, unidentified Mesonychians, and many species of basal cetaceans and their relatives. These were represented by the Rauelids, which were among the most common mammals at the formation. These small artiodactyls represent the sister group to cetaceans, and probably resemble the earliest ancestors of modern whales and dolphins. By far the most famous was the genus Indohyus, a cat-sized omnivorous animal that would have resembled a cross between a long-tailed pig and a chevrotain. Living around waterways, little Indo-Hyas was probably a skittish forager, with its heavy bones indicating that it spent a lot of time in the water, almost certainly as a means of escaping from predators, while analysis of carbon isotopes in its teeth suggests that it mostly fed on land. Another less well-known rowelid present here was Keartharia, which was a younger animal than Indo-Hyas, living between 48 and 45 million years ago. Its caniniform incisors and crushing bunodont molars indicate a more carnivorous diet than its more famous cousin, with the living animal being a semi-aquatic omnivore. Early crown group cetaceans were also numerous at the Kuldana Formation, with most of these being members of the family Pachycetidae, named after the famous type genus Pachycetus. Looking more like some unusual member of the canid family, Pachycetus was very different in appearance from modern cetaceans, and its body shape more resembled those of land-dwelling hoofed mammals. Unlike all later cetaceans, it had 4 fully functional long legs that ended in digits tipped with small hooves, enabling this genus to walk about effectively on land. Pachycetus had a long snout, a typical complement of teeth that include incisors, canines, premolars and molars, a distinct and flexible neck, and a very long and robust tail. As in most land mammals, the nose was at the tip of the snout, while it also nonetheless possessed key adaptations for a semi-aquatic lifestyle, including dense bones, eyes placed at the top of its skull, and teeth well suited for catching fish. Like all other cetaceans, Pachycetus had a thickened skull bone known as the auditory bulla, which was specialised for underwater hearing. 4 species are known, which range between 1 to 2 metres in length. Several other genera of Pachycetids were present at the formation as well, such as Ichthyolestes, which was a smaller and more slender animal than Pachycetus, being the size of a small dog, albeit with a long heavy tail. More derived cetaceans were present here as well, with Insular India proving to be a haven for the diversification of these mammals. These included the larger 3-metre or 10-foot long Ambulocetus, which would have resembled a furry crocodile, with elongated snapping jaws and paddle-like webbed feet. It was probably an ambush predator, lurking at the water's edge and waiting for terrestrial ungulates to come down for a drink, then bursting out of the river and seizing the unfortunate prey by the head or throat. It may have also targeted other semi-aquatic mammals like early Sirenians, in the brackish river mouths and deltas in which it lived. On land, predatory mammals were present in the form of the hyenodonts, although these remained relatively modest in size. Instead, the most massive predator of early to middle Eocene Insular India was the gigantic snake Vasuki indicus. A member of the Matsoiidae family discussed earlier, this enormous predator potentially measured between 10.9 to 15.2 metres, or between 36 and 50 feet long, making Vasuki possibly longer yet lighter than the South American Titanoboa. Also, unlike that animal, Vasuki was probably not an aquatic snake, spending much more of its time on land. It dwelt in a tropical marshland ecosystem, which is an environment similar to that inhabited by large modern pythons. The snake probably lurked in the undergrowth, waiting to ambush the semi-aquatic mammals that lived alongside it, such as the otter-like early cetacean Cuchicetus and early Sirenians, crushing them to death in its coils before swallowing them whole. Matsoiids as a group survived in India until the late Oligocene, well after the island subcontinent had fully collided with Eurasia during the late Eocene circa 35 million years ago. Most of the endemic groups present here were not so lucky, with modern South Asia possessing largely Eurasian animal and plant communities. However, as mentioned earlier, some of the old Gondwanan groups have gone on to great success, including the Asian mantises and the tropical dipterocarp forest trees, which have spread throughout Southeast Asia and the Malay archipelago. In addition, although artiodactyls evolved on the northern continents, cetaceans first appeared and radiated on Insular India before gaining a global distribution. Gondwanan-derived tetrapod species are notable by their presence in the Western Ghats, a wet, biodiverse mountainous region that is home to the legless Sicilian amphibians, the Gehalopid blind snakes, and the bizarre, so ugly that they wrap around to being cute again, purple frogs of the genus Nascia batrachus. Interestingly, the closest relatives of these frogs are the zooglossids, which were endemic to the Seychelles Islands. These two groups diverged during the Late Cretaceous, when these islands split away from Insular India, demonstrating the northward path taken by the region that would later become South Asia. Thanks for watching, everyone. The next episode we're covering the bizarre and hard to classify diadectomorphs, which may or may not be crown group amniotes from the late Carboniferous and Permian, producing some of the first large herbivorous land vertebrates. See you again soon. Cheerio.